So, I said like drilling, when you are doing, you will have one mud means actually fluid, okay. Sometimes this is called drilling mud or drilling fluid also they say, drilling fluid, okay. So, you have seen this drilling for your metal, making hole on wall or metal drilling you have seen, right. So, it will be having like one screw type thing, right, one screw type thing will be there, right, and you rotate it continuously and give pressure and you make hole on wall or metal or anywhere like wood, right. So, this was a similar mechanism actually when you are going for offshore or onshore any drilling for oil and gas, okay. So, you have one long pipe, and pipe will have one at the end one cutter will be there called drill cutter or drill bit, okay. So, one pipe is here, at this end one drill cutter or drill bit, okay, drill bit will be there. So, continuously you give little bit pressure and rotate it. When you are rotating, what is happening? This cutter will be cutting the rock, okay. Earth surface, on the upper surface of earth very softer rock will be there, but if you go inner the rock strength will be more stronger. So, in that case you have proper drill bit rotating continuously, it will be cutting. But again when it is cutting, you may have noticed when you drill any wall with your normal drilling machine or any metal, it will be generating lots of heat, okay. If you are not removing heat, it can break actually, okay. So, in your oil and gas drilling operation, what do? You inject liquid or fluid or drilling mud. So, the drilling mud will, this drill pipe inside hole will be there, you inject lots of fluid and it will be passing through the drill bit and it will be moving up, okay, and it will take lots of heat. So, purpose of drilling mud is cooling, it will lubricate also, okay. So, drilling mud purpose, drilling mud purpose. So, one I said cooling, okay, because it is getting lots of friction, it will be getting heated up, okay. Friction means heat. Finally, any form of energy, final form is that heat. When you are converting one form to another form, energy, chemical or any other. So, final form energy loss is happening, like you may have studied like thermodynamic equation, thermodynamic laws, second law, first law, right, you can remember. So, in second law you have learned that energy loss will be there when you are converting one form to another form energy, right. So, that lost energy actually it will be converting into heat, final form of any energy is heat. So, whenever you are drilling actually final form will be heat, whatever you do finally it is generating heat, okay. Lot of friction will be there, rock cutting is there, breaking is there, heat generation is there. So, you have to remove the heat. So, for that you are giving high velocity drilling fluid, so that heat will be dissipated, drilling fluid will take the heat, okay, and it will be lubricating also, so that friction will be reduced, lubricating like you are driving cycle, right. So, if you do not drive cycle for like say 6 months during lockdown, I think you can remember several days you do not drive your cycle and cycle will be making noise, it will be very difficult to drive. So, in that case what you go to cycle shop, they will be putting some thick fluid or some grease or some mobile oil sort of they will be putting on your cycle, right. So, that is actually lubricating oil, long chain hydrocarbon, not short chain, long chain hydrocarbon that will create lubricating effect. So, that lubricating effect will reduce friction. So, in that case also you are reducing friction using your drilling mud, you are cooling. Another work is that whenever you are cutting a rock, lots of small gravels will be created, broken rock called drill cutting, okay. So, drill cutter will be cutting. So, they say cutting or drill cutting or rock cutting, whatever terms you use. So, those rock if it is getting deposited, then drill bit will get clogged there, okay. So, you have to remove that rock particle. So, how will you remove? The drill mud will go through this hole of this drill pipe, and when it is going up, it is going through this hole and it is going from outside. How it is like this? Like I have one wellbore and my drill pipe is here, okay, and my drill bit is here, and liquid or drilling mud is coming and it is cutting continuously this rock. and this drilling mud will be moving up. Okay. So, the drilling mud you are pumping through the drill pipe, this is drill pipe, and this is annular area actually, this is called annular area, annular area. Annular area means you cut a hole, drill pipe is here. So, in between drill pipe and your hole, the space is called annular area. Okay. So, mud will be moving up through the annular area. Okay. So, mud when it is moving up, it will take all the cuttings also, small rock particle whatever you created, that will be moving using moving by your drill mud. Drill cutting removal, right? Cutting removal, REMOVAL. So, it will be removing drill cutting. Another task is that hydrostatic pressure. What is hydrostatic pressure? Hydrostatic pressure means when you are cutting your cutting the wellbore. So, what happens? Let us say surface rock is there, then after that maybe one formation zone is there, and pressure is very high at the formation zone, and you cut it and you reach the formation zone, high pressure fluid is there. So, high pressure fluid will try to move towards the drill pipe and all the annular area. So, if you do not control that high pressure fluid wellbore to your surface coming through your annular or drill pipe, then accident can happen. Okay. So, to prevent that one, what you do? You change the drilling mud density such a way that whatever pressure is there in wellbore reservoir, you create more pressure here, okay, or almost equal pressure. So, that whatever pressure you have, that pressure will not force fluid to go up. So, drill mud will control all this flow phenomena. If reservoir is controlling flow phenomena, then it is dangerous actually. If gas is there, oil is there, then suddenly it will be gushing out, and if there is any fire source, then whole things will get burst. Okay. So, in that case you are maintaining hydrostatic pressure, drill cutting removal you are doing, cooling work you are doing, lubricating you are doing, and some other purpose also there, for example cake formation, other things are there, we will not discuss in details. Okay. So, you see the left side picture I have taken from Encyclopedia Britannica. Here you see drill cutter is here, drill bit is here, okay, drill bit, and fluid is coming through this, you see this arrow already given, okay, this is drill pipe if is shown here, drill pipe, okay, and fluid is moving up through the annular area, okay, and from where the fluid coming actually, you see one pump is here, left side, mud pump. So, mud pump will be pumping fluid, drilling mud at very high velocity or high pressure. Mud pump normally it will be reciprocating, because very high pressure you have to create. So, normally it will be multi-cylinder reciprocating pump, maybe diplex, simplex, quadruplex, that sort of reciprocating pump which will create very high pressure. Later I will discuss why not centrifugal or axial pump, why is reciprocating pump. Reciprocating pump can create very high pressure. So, high pressure pump you are creating, you are delivering high pressure fluid through this mud hose, then it will go through drill pipe. Kelly means the top section of drill pipe, one conduit or pipe is called Kelly, the top section. So, that will be rotating continuously actually, and Kelly will be connected to your drill pipe. So, fluid is going through this. Okay, then when you are returning fluid will go directly to this shell shaker. This vibrating screen is called shell shaker. Shell shaker, SHAKER. Okay. So, continuously it will be vibrating. How? Whenever drill mud is coming back, it will have lots of rocks. So, this shell shaker or vibrating screen, actually lots of pores will be there. When you are continuously shaking like this, so sand particle or bigger particle will be standing over this shell shaker or screen, and liquid will be falling down, okay, and you separate the top part, okay, you are cutting, you do not need you handle that one separately, and liquid you put in your mud pit, okay, mud pit. Why mud pit you have to put? Actually mud pit you are giving settling time, so that rock, small particle, debris, anything is there, they will be getting settled in mud pit. So, from mud pit after settlement you pump it again, okay, then you recirculate. So, this is actually continuous circling operation. So, pump to hose to Kelly, drill pipe, drill bit, annular area, okay, annular area, then again it is coming to shell shaker area, descender also will be there on hydrocyclone or descender may be there, then it will go to mud pit, then again mud pump, again this circulation will go on. And many cases you have to change drilling fluid property. For example, sometime you have to increase density, sometime decrease density, sometime increase viscosity, decrease viscosity. That one we are not discussing here in details, okay, because our focus is different for this course, because all topics are different also, small topics, so that someone coming first time, so they should remember those terms, especially they should not know, if someone like learning first time, they should understand the terms like drill cutting, mud, all these terms whatever you are using, those terms if you are not petroleum engineers actually, so you have to go through Wikipedia or some other sources and you have to be familiar with the terms, okay. Okay, so drilling stage. So, in previous slide you have seen we have wellbore and we have drill pipe and you have their cutter, okay. This is drill pipe, and this is your rock actually, you already removed material from here, okay. Now, you must have one wellhead, okay. During drilling operation you can have one wellhead. So, wellhead will allow accessing your wellbore, putting your tubing, everything, but that time your Christmas tree may not be there, okay. And there actually you will have one BOP also. What is BOP? Or blowout preventer, blowout preventer, blowout preventer. So, a blowout preventer, what does it do? Like say you are drilling and suddenly you got one area, this is very high pressure, maybe high pressure and having gas, okay. If you have cap rock and when you are drilling first time, so cap rock top portion may have gas accumulated, okay. So, you suddenly drill and you get very high pressure gas. So, high pressure gas, what will they do? They will try to move this move up, okay, through maybe your drill pipe or through annular area, and if suddenly you get that much of high pressure, that is called kick, okay. So, if driller or the engineers who are working, if they find some kick is there, suddenly pressure is getting changed. So, what will they do? They will change their drilling fluid density or other parameters, so that they can control the kick and they can continue drilling. But in some cases that is not possible to control. So, there will be one mechanical arrangement called blowout preventer. So, blowout preventer means suddenly kick is there, but drillers or those engineers working there, they are unable to handle. The blowout preventer, the mechanical arrangement, it will take action. So, suddenly it will close the whole pipe. In some cases it will be cut the whole operation, it will stop whole fluid flow, okay. So, there will be no outflow. If something is going out, gas or oil, if there is any fire source or anything, then blast can happen. So, that happened actually in Deepwater Horizon. So, suddenly fluid gushed out and they did not control it, and I was reading their report and they found that like everything was designed nicely, but their IC engine, internal combustion engine was there. So, internal combustion engine should have certain specific fuel air ratio, so that engine will be working properly. But what happened, because of gushing out fluid gas, so the gas changed the air fuel ratio and it entered the engine. So, engine did not function properly because it got more fuel than required fuel, okay. Whatever gas were coming, that is also fuel, and engine had its own fuel. So, altogether the ratio changed and fire started. Once fire started, done, no one can control immediately. And when you are working for offshore, actually your life also linked with that, you cannot run away, okay. You are working on semi-submersible platform and you are thinking some other engineers will be working, I will be sleeping for today. So, not possible, your life also linked there, okay. So, all engineers were involved, they started working, but finally 11 engineers died immediately, I think. Okay. Then after that, British Petroleum and other organizations, they handle, I think they are getting production now. So blowout preventer will be activated when drillers are unable to control the kick. Okay. So when you are drilling a hole, so hole can be completely vertical. Your life is easier if you have land well and you are drilling completely vertical. So life is beautiful, you do not have any tension. But many cases you will not get sufficient production. Let's say you have very thin layer of formation area. Okay. So you want to get more production. So thin area means your wellbore connectivity and your reservoir only this one. But if you want to get more production, what smart engineer will do, they will make horizontal hole like this. So their connectivity between wellbore and reservoir will be more, okay, longer connectivity possible. So they will get more production. So to increase production, they will go horizontal. In some cases, they will go for multilateral wellbore. What is multilateral? You drill a vertical wellbore, then you make branches. Okay. Some can go horizontal, some can be vertical, some anything. Okay, many options possible. Why? Let us say you have one formation area here. Okay, this one, and you want to get some production, but you found further deeper also there is another formation area. Okay, you have to get production from there. So you can get one production here, another production here. Okay, so again if think like one wellbore offshore area, you cannot drill many wellbore in offshore area. One platform is there, like a huge expensive platform you have built. You should go multilateral, and you can access many reservoir area, many formation area, and you can get your more production. Okay. In some area accessibility is one issue. So in that case you can go horizontal, you can create S-shaped wellbore, you can create other shapes of wellbore also. For example, here rough or remote locations where accessibility difficult, desert area may be there, or maybe forestry area is there, or maybe ocean area is there, offshore area. So one platform is there, you cannot buy many platforms because it is very huge expensive. So you create only one platform and you try to access all the nearby whatever reservoir area is there. Okay. In an undercity, for example, I gave example, IT Madras will not allow you to drill here. So you have to go maybe Marina Beach or somewhere else. Then you drill there and you access. IT Madras will not know also. Okay. But if it is coal, normally you have to inform IT Madras. They will have to vacate, because coal means you have to remove the material. In oil and gas, normally you are not removing the material, only liquid you are moving. All right. Geological isolation, some fault is there, so you have to check that fault area and you have to drill accordingly. Okay. So the wellbore shapes can be like this, completely vertical. Okay. You create vertical wellbore, you perforate here. Maybe it will be slanted wellbore. Okay. Based on your reservoir condition, productivity, your target. So Bombay High initially they drilled vertical wellbore, later they went horizontal also to get more production actually. And you can create almost L-shaped. Okay. Sharp corner not possible, but almost L-shaped wellbore you can create. You can create like little bit up, you can create multilateral, okay, branching, lots of branching you can create. You can go horizontal, you can create multiple branching like this, horizontal, you can create horizontal, maybe a shaped, so many shapes you can create. So engineers, every engineer will have their own policy and reservoir condition, many parameters are there to decide. Randomly you cannot say I will be going for horizontal wellbore or vertical wellbore. So there will be several parameters to decide that. So those reservoir engineers and other engineers, they will decide, okay, this is the possible way, and they will instruct drill engineers, okay, this is the cases. So you drill that way, then driller will take action. Casing and cementing. When you are going for drilling, okay, so first you drill a very wide hole, okay, then you put one casing, that is called conductor pipe or conductor casing. Okay, this is called conductor pipe or conductor casing, many people will say. Okay, then you cement it. So I am hashing this one. This means this is cemented area. Then you put another casing. This is called surface casing. Again you cement. Okay. Okay, this is called surface casing. And then again you put another casing. So gradually you are reducing the diameter. Okay, you are making everything safe. initially you drill a few feet, you put conductor casing, okay. Then after that you drill another little bit more, maybe 200 feet or something, then you put one surface casing. So, when you are putting surface casing, actually you are preventing oil and gas, not allowing oil and gas to invade into your aquifer zone, where drinking water will be there or trees will be surviving there. So, you cannot allow oil and gas to go there, okay. So, that is why you are putting surface casing. So, surface casing again you cement, then there will be again another casing. So, several stages of safety you are putting actually nearby surface area. Then you are putting surface casing, then you are putting intermediate casing, okay. After intermediate, again you are putting another casing, there is a final casing, that will be called production casing. So, that one you can perforate, this is called production casing, CTION, okay, production casing. So, conductor casing or conductor pipe will have a larger diameter, like maybe 36 inches, that sort of. When it is going to production casing, it will be like 5 inch, 5.5 inch, so that area. So, you can see gradually it will be reducing one by one. And the purpose of conductor casing is like it prevents unconsolidated sediments from entering into the bore, okay. And if you go to surface casing, so it will be protecting the freshwater zone. Freshwater zone you cannot contaminate during production stage or any stage actually, okay. And it will be attached to BOP also during drilling operation, okay. And it will be giving its structural integrity, it will be connecting to other type of casings, fine. And production casing set across the reservoir. So, production casing will be connected to reservoir, okay, in the bottom one, within which the primary completion components are installed. Primary completion components, for example, your sand control equipment will be there, perforation and all this artificial lifting mechanism all be there at the production area, okay. And intermediate casing will be very long actually, its function actually only just to support, okay. So, wellbore completion, once drilling is done, you will be completing wellbore. So, when you are completing, actually you will be cementing, then you will be perforating, then you will be fracking, hydrofracking will be there, acid fracking will be there. Maybe some cases you will be putting artificial lifting mechanism also, those are part will be part of completion process. Many big company they will have separate team of completion engineers, but very small companies they will have only drilling people, they will be doing all the job, okay. So, when you are going for completion, actually there will be two type of completion, will be lower completion, will be upper completion. Lower completion like this, you have a drilled hole, and upper completion will have like wellhead, Christmas tree, and you will have choke also. So, those will be part of upper completions, okay, upper completion. And lower completion will be like creating here sand control, okay, sand control mechanism will be, perforation will be there, your putting other mechanical arrangement will be there, okay. So, whenever you are going for lower completion, there will be bare foot completion, like you have consolidated sand. So, in that case you may not put any casing, okay. Without casing also you can get production, that is called barefoot completion, okay. In some cases pre-drilled slotted liner, in some cases you have wellbore, okay, like this, and you have put some pipe with lots of slots, okay, pipes with lots of small holes, this is called pre-drilled slotted liner, okay. This is pre-drilled slotted liner, this is barefoot completion. Cemented and perforated, in many cases like you have wellbore, okay, and you have casing, you put cement, okay, unconsolidated sand may be there, so that sand will not enter into wellbore, then you perforate, you make long hole, okay. So, this is called cemented and perforated. So, put casing or pipe, sometimes we say drill pipe, casing, actually metal pipe, tubing also metal pipe, okay. The oil and gas uses specific terms, so those sometimes those terms will be very odd, but they use this, for example, rat hole, mouse hole, monkey board. So, lots of terms will be there, if you read then you will get those the idea of the terms. Here also casing means actually metal pipe, tubing also metal pipe, Kelly, and then drill pipe also, all metal pipes. Okay. So, casing is metal pipe. So, you put metal pipe, you put cement all around. So, you drill a hole, put metal pipe, put cement here. So, that pipe will not move, okay, and there will be no leakage also. Okay. Then when you put pipe and cemented, actually no fluid can enter into wellbore. So, what you do? You put lots of holes. There is some mechanism called perforation mechanism. You create perforation and you create connectivity between reservoir and your wellbore. So, that fluid will be entering into your wellbore slowly. Okay. So, one option is that cement completely and perforate and you get production. Another option, open hole sand control system. So, sand control system is so why sand control actually? Sand control means, like say you have reservoir, you drill a hole and you have tubing or casing, whatever you put. Then whenever you are getting oil and gas production, so some small sand particle also can come into wellbore. Okay. If large amount of sand is coming, that is a problem. Problem is that it will be blocking everything. Okay. You have one pipe, okay, and sand also coming. So, sand, because higher density than water or gas or oil, so sand will be getting accumulated at the bottom. So, when it is getting accumulated, slowly it will be blocking the path. When it is blocking, so fluid, say oil or gas will not enter into wellbore and it will not go up. Okay. So, reservoir pressure sometimes will be very high, it will be pushing oil and gas and it will create natural flow, automatically fluid will be coming to your surface. Okay. In many cases, reservoir pressure may not be sufficient. In that case, you may need to some extra energy from artificial lifting mechanism or EOR technique, enhanced oil recovery technique, to increase reservoir pressure or fluid pressure, so that it can go to surface. And reservoir, if there are lots of sands are there, then you have to control the sand there only, otherwise sand will come, it will block your path, or sometimes it will be eroding metal pipes. Okay. If hydrogen sulfide is there, hydrogen sulfide means H2S plus water, it will create actually acid, H2SO3, H2SO4, it is acidic gas, okay, sour gas they say. If H2S is there, again sand also coming, actually corrosion and erosion will occur together. Then whole metal system, your whole production system will get hampered. So, you have to avoid sand, you have to avoid H2S, but if H2S is coming, you cannot do anything, but you have to handle, you have to select material property and you have to design such a way that whole system will be stable for longer duration without leaking, without any problem. But if you have sand, then you have to put some sand control equipment at the bottom, so the fluid will be coming, but sand can be prevented. You create small net, so the sand can be stopped there and liquid or gas can enter into wellbore. Okay. So, very small net actually. So, that is called sand control equipment. So, many cases there will be open hole sand control equipment. So, it is open hole and you put some sand control equipment, standalone screen, other screen. In many cases you put cased hole, like say casing is there, you put cement also, again sand control equipment, because still sand coming. You cased it, cased means metal pipe you put cement also, then you perforate and you connect it with reservoir and you are getting production, still sand is coming. So, in that case sand coming, then it will be blocking whole thing. So, you put some sand control mechanism, so that sand can be stopped there. Okay. So, your productivity can be maintained. And again, there is no ideal sand control mechanism. If you want to prevent all sand, that means you have to stop the whole production, because there will be sand particle which will be coming with liquid, whatever water, oil, gas you get. And any wellbore, whenever you are getting your production, actually you get oil, water, gas, sand. Okay. And water is free actually, it will come. In one wellbore's life, it will be producing more water than any other fluid. Okay. So, water will be coming and sand will be coming based on your consolidation, your sand control equipment. And if you put very good sand control equipment, means you are reducing your productivity. Okay. That means you have to put very small net size very small. So, in that case your fluid also will get resistance, sand also will get resistance, fluid also will get resistance. Okay. So, your productivity will go down actually. But if you want to get more production, you have to get, in many cases actually people will try to take sand, they will say okay, allow sand, we will handle on the surface. Okay. So, there will be some engineers, but not every cases, but some engineers will be very much confident, they will do that sort of work, but all engineers cannot do that. Okay. Again, when you are a production engineer, so you have to give maximum productivity, you have money actually finally. So, your company boss will say how much money you are getting. If you are asking, sir, every time separator is getting blocked because of sanding, then they will replace the engineer. Okay. Because I am paying you 2 lakh, 5 lakh rupees per month, and every time I am replacing my separator system. So, that is not good, right. So, you have to create that optimization, how much sand control equipment I will put and how much sand you can accept, so that my productivity will be stable and will get more benefit to the company. So, you want to go? Okay.